This video lesson is for Chapter 1, Section 7. We'll be discussing bisectors. We'll start off with the first bisector, or just the word bisector in general. Bisect, cut into two equal parts. So when we place segment bisector, we're looking for a point that divides that segment into two equal parts. And we've already defined that idea as a midpoint. So our segment bisector definition is a line, segment, or ray that intersects a segment at its midpoint. So a segment bisector is not just the point, it's the line or the segment or ray that goes through the midpoint. That becomes the actual bisector. So if we look here, we have a line, TV, and a segment, SO. They are intersecting at point E. If we make the statement that line TV bisects segment SO, what conclusion can we make according to this definition? Most of the time, we want to jump to the congruent parts. But the real conclusion that can be made if line TV is bisecting segment SO is that line TV is going through the midpoint of SO. So therefore, our conclusion will actually be E is the midpoint of segment SO. Now, we need to make sure and understand that TV is the segment bisector. Segment SO is what is being bisected. There's something that's doing the cutting and something that is being cut. Now, we know that E is the midpoint of segment SO. Our next statement is here. If E is the midpoint of segment SO, what conclusion can we make from our previous lessons? Now, we make the conclusion. Segment SE is congruent to segment EO, and the markings are added to the picture. This is consistent with the word bisect, cut into two equal parts. Here are the equal parts, segment SE, segment OE. It is very important when we see segment bisector that we add two things to our picture. We should note and write down that E is the midpoint of SO. We should also mark down the parts that are congruent. Notice E is not the midpoint of TV and does not create any congruent parts on TV. TV is the thing doing the cutting. If you took a piece of string and held it out and cut it with scissors, you wouldn't say that the scissors got cut in half, just the piece of string. So if line TV cuts segment SO perfectly in half, then E must be the middle of segment SO. This is our first bisector. The next bisector we're going to look at is perpendicular bisector. However, in order to do this, we must first look at the word perpendicular, a word that we should be familiar with. The word perpendicular means that two lines will intersect to form right angles. So, in an if-then form, if line AB is perpendicular to, this upside down T is the symbol for perpendicular, and it is read, is perpendicular to. Line AB is perpendicular to line CD, then the conclusion is all of the right angles formed at the point of intersection are right angles. Here we have the picture. Line AB, perpendicular to line CD, all four angles are right angles. Now it turns out that we only need one right angle in order to have perpendicular lines. We've learned that angle A, we'll call this point O, D, and angle AOC are a linear pair or supplementary angles. They add up to 180 degrees. If one of them was a right angle, which is 90 degrees, then the other one would also have to be a right angle, 90 degrees, in order to make 180. We could continue around the entire intersection showing that they are all 90-degree angles. So, if two lines are perpendicular, They intersect to form right angles. This would be a shorter definition of perpendicular lines. Perpendicular lines intersect to form right angles. Now, we might be able to look at this in a little bit of a reverse nature. For example, what conclusion can we make if we were told two lines intersect to form a 60 and 120 degree angle? And the conclusion here is that these lines are not perpendicular. Because if they were, they would have to form right angles. So, if they form 60 or 120 degree, which means if they do not form right angles, then they are not perpendicular. Later, in level 2, we're going to study that this is what is called the contrapositive of this statement. If they are perpendicular, then they form right angles. If they don't form right angles, then they're not perpendicular. We could actually do this in all different ways. If they form right angles, they are perpendicular. If they are not perpendicular, then they don't form right angles. This definition is very reversible. You can negate it. Perpendicular and right angles must go hand in hand. So we will skip this question because we already answered it, that 60 and 120, they are not perpendicular. It'll be choice C when we go over this in class. Now, perpendicular bisector is where we're going. These are the two words, putting together the two words that we have just talked about. If line JK is a perpendicular bisector of segment XY, then the angles are right angles, and Z is the midpoint. We need to recognize that perpendicular bisector is not one word. It's two. Perpendicular, right angles. Bisector, midpoint, creating equal parts. So the perpendicular portion of this is shown with the right angle. Remember, we only need one. The bisector portion of this is shown with the congruent marks, establishing that Z is the midpoint. So, we have XZ is congruent to ZY, but we don't have JZ congruent to ZK. Again, line JZ is the bisector. It's the pair of scissors doing the cutting. Does not get it cut. XZ congruent to ZY because XY is the bisected piece. Perpendicular, bisector. Remember, it is two words. When we say perpendicular bisector, we get two conclusions. Right angles from perpendicular, midpoint from the bisector. Finally, we have angle bisector. An angle bisector is any line segment array that divides an angle into two congruent angles. This is very true to the word bisect. Bisect means to cut into two congruent parts. So, here in this picture, ray AT is intended to be the angle bisector of angle MAH. This would cause us to come to the conclusion that angle 1 is equal to angle 2. Or we could take a pen and mark that into our picture that angle 1 is congruent to angle 2. This might help us in a solving problem where we have to set the two parts equal to each other in order to solve for a variable. In if-then form, if ray AT is an angle bisector of angle MAH, then angle 1 and angle 2 are congruent. We know that this is a good definition because it is also reversible. If we start with angle 1 and angle 2 being congruent, we can conclude that ray AT must go through the center and is an angle bisector. We will not be showing any examples of the work you might use these definitions for. Rather, I will challenge you to think about the definitions. What do the words give you? Bisector is going to give you equal parts. find those parts and set them equal to each other. Perpendicular is going to give you a right angle. Right angle means 90 degrees. If you have to find the measure of the angle, work with 90 degrees. That's it for Chapter 1, Section 7. This video lesson is actually going to cover 2 sections, so right after this, we'll start Chapter 1, Section 8 on the distance and midpoint. This is part 2 of video lesson number 5, where we'll be covering Chapter 1, Section 8, the distance and midpoint formulas. I'm going to start off with a mini lesson that is not so much for notes, but more for the visual and listening to what's going on, of understanding where the distance formula came from. On the screen, what we have here are 2 points, point A and point B. I've also included a point C, which is directly to the right of A and directly below directly below B, in order to form a right triangle. What I want to look at is the distance between A to B. Here in the corner I have the coordinates for A. It is at 3 to the right, 2 up. B is at 11 to the right, 8 up. And C is at 11 to the right, 2 up. Notice that the left-right coordinate of B and C are the same, and the up-down coordinate of A and C are the same. This is going to be important to understanding where the distance formula comes from and how it is connected to a famous formula that most of us know. First, we're going to look at the distance from A to C. A to C is horizontal. It does not move up and down. So we only have to look at the coordinates of the x, 3 to 11. We've talked about distance is difference. On a number line, if I am going from 3 to 11, the distance is 8 spaces. We find this by taking where we finished, 11, and subtracting where we started, 3. 11 minus 3 is 8. I want to keep in mind that the x-coordinate of the C value is the same as the B value. So going from A to B, we have moved 8 spaces horizontally. Then we look at C to B, the vertical change. It goes up from C up to B, or you could say down from B to C. And if we do this, it goes from 8, which is where we ended at, up here at up 8, and we started at 2. 8 minus 2 is 6. Now we can see the vertical distance, the rise of this problem. So we have 11 minus 3, 8 minus 2, gives us 2 sides of a right triangle. 8 here, 6 here. Okay, and again, notice that the y value of the C is exactly the same as the y value of the A. Okay. So now we're going to look at the Pythagorean theorem. The Pythagorean theorem tells us that if you add the sum of the squares of the 2 sides of a right triangle, it will be equal to the square of the hypotenuse. So a squared plus b squared will equal c squared. Now AC happens to be the horizontal, CB the vertical. So this allows me to take and say that if I take the square root of both sides, I get the square root of AC squared, and here's AC, 11 minus 3. Here's CB, 8 minus 2. This eventually leads us to the distance formula. The x of the B, which is the second point, minus the x of A will tell you the horizontal squared. The y of the B minus the y of the A will tell you the vertical, and we can square it. In this specific case, you have 8 squared plus 6 squared. That's 64 plus 36, which is 100, and the square root of 100 is 10. This segment is 10 units long. So the main thing that we wanted to gain from this slide is that the Pythagorean theorem is where the distance formula came from. And we could use the Pythagorean theorem to help find distance. It's one of the methods. So, let's look at the two formulas that we'll need to be using, distance and midpoint. First, as we just saw, the distance between any 2 points, A, which is x1, y1, and B, which is x2, y2, is this formula. The square root of x2 minus x1, that's the horizontal, squared, plus y2 minus y1, that's the vertical, squared. If you need more time to write down this formula, just pause the video. As for midpoint, the midpoint, I like to think of the word average. You're trying to find the point that is directly in the middle of the segment. Well, again, we're going to look at horizontal and vertical. We're going to take the two x values and add them together, and then divide by 2. This will give us the average between the two left and right values. Then we will add the two y values. And the y values are the vertical, or up and down. When we add them together and divide by 2, we will get the average of those two values, and the average will be the middle. So it's important to think of midpoint as being the middle or average between the points. These are the formulas that we'll use. We're going to go over to the sideboard and take a quick look at an example, and then we'll be done. Okay, so here's our first example of using the distance and midpoint formula on 2 points. The problem says find the distance and midpoint between point A and point B, given that point A is at 2, 1 and point B is at -4, 3. Now, we could just go right into using the formula, which would be method 1, in which we take x2, -4, and subtract x1, 2, and square it. We then will take y2, which is 3, minus y1, which is 1, and square that. This becomes the square root of -6 squared plus 2 squared. The square of any negative number becomes positive, so -6 squared times -6, or -6 times -6, becomes 36. 2 squared is 4. We have to add these two values before we take the square root, because the square root symbol is like grouping. You have to do what's inside first. So we get the square root of 40. Now we could go to our calculator at this point if we have been asked for an approximate answer or decimal answer. If we're asked for an exact answer, which is very important, we would break this down into the square root of 4 times 10, in which the square root of 4 is 2, and 10 we do not know the exact square root of. This would be the exact answer. Now, if we didn't want the exact answer, we would go to the square root of 40 on our calculator. Now that I magically have a calculator in my hand, we can take the square root of 40 to find that it is 6.3. This would be the approximate answer, in which we might want to put the approximate symbol in front of. This is method 1 and the most common method, which is to use the formula. If you didn't end up using the formula, if you needed the visual, here are the points 2, 1 and -4, 3. We could take this and make a right triangle. From that right triangle, we could look at the distance that goes from 2 to -4 and claim that it is 6 spaces. We can also look at it going from 1 to 3 and claim that it goes up 2 spaces. Once we draw this right triangle, we could use the Pythagorean theorem. 6 squared plus 2 squared equals c squared. This will give us the 36 plus 4, which becomes the 40, and we can take the square root of both sides. This will lead us to the exact same answers. So there are two methods. We can apply the formula where we put the points in and substitute the values in for x1 and y1, x2 and y2. Or we could draw a picture by plotting the points and estimating where it is and creating a right triangle in order to use the Pythagorean theorem. as we move forward, we want to find the midpoint of these 2 points. Here we will just use the formula, and we will say that it is x1 plus x2, 2 plus negative 4, all divided by 2. And then we will take 1 plus 3, which are the y values, and divide them by 2. This will produce negative 2 over 2, comma 4 over 2, and a midpoint of negative 1, comma 2. If we look on our picture, left 1, up 2, there is our midpoint. We'll now go and do one more example of how to work with midpoint, and the lesson is done. This is our second example of how to work with the midpoint formula. In segment AB, the midpoint is at negative 1, comma 1. If point A is equal to 3, comma negative 5, we need to find point B. So the difference here is we've been given the midpoint and we've been given an endpoint. An interesting way to look at this is just on a strictly horizontal line, and I'm going to go away from just plugging into a formula and rather get into the idea of what a midpoint is. If point A is here at 3, comma negative 5, and the midpoint is here at negative 1, 1, what I want to look at is this idea of if you started at an endpoint and went to the midpoint, how much further do you need to go to get to the other endpoint? The idea of a midpoint is that you're halfway. If you've run 3 miles and you've gotten to the halfway marker of a race, you know you have 3 more miles to go. So when I look at the x value, 3, and I have to go to negative 1, I have gone to the left 4 spaces, and I am halfway there. So what should I do? I should go to the left 4 more spaces. Now, 3 minus 4 is negative 1. Subtract 4 again, and you're at negative 5. We can do the same thing for the y values. We have gone from negative 5 up to 1. This is a change of 6. Negative 5 plus 6 is 1. So if we're halfway there, we should add that on again. Add 6. 1 plus 6 is 7. This is probably the fastest way to finding the endpoint given a midpoint. We can always check to see that our work came out and got the correct answer by adding 3 plus negative 5 divided by 2. Negative 2 over 2 is negative 1. The y values of negative 5, this negative 5, plus 7 divided by 2 will be 2 over 2, which is 1. Negative 1, 1 was the midpoint, and we were successful in this work. That concludes Chapter 1, Sections 8 video lesson, and this is the last video lesson for Level 1.
Nice job, Dad.
Thanks, Hayden.